All right. So we talked about automation, and now we get to talk about the really cool stuff, which is the more developer-focused stuff. Yay! All right, so basically this session is going to be a little bit about starting from my local machine, working with a Java stack, how to deploy that and how to automate that a little bit. That's the premise of this talk. So who am I? I'm Kevin Dubois, and I don't know if you've been following the whole Twitter saga with Elon and the drama, so I figured, I'll put on my Mastodon as well. So, if you want to keep up with things, I post kind of random things, mostly developer-focused, Openshift, Quarkus, those kinds of things, but feel free to follow that. And if not, so who am I? I'm a developer advocate at Red Hat, previously software engineer, I speak a couple languages, but I'm mostly passionate about the developer experience with open source. I'm a big fan of open source, and so, nice that I get to do that at Red Hat. So basically, you've decided to create an app, or maybe you already have an application and you want to make that more cloud native, or maybe you have a cloud native app and you want to see, how can we improve that. But so basically the approach that I'm taking is I'm starting from scratch. I want to create a new application, and so, now we need to think about where do we begin, because I need to think about, what kind of stack I want to use, right? Do I want to use a Java stack? Do I want to use Go? Do I want to use Python? Lots of questions there. How do we build this application then, in terms of, in Java, how do we compile it? How do we package it, as a jar, as ER/WAR? And then, do we put it in a container? And then where do we deploy it? And or how do we deploy it? Because sometimes the where is what gets decided first, and sometimes it's the how that gets decided first, right? So we have to make decisions based on how and where and what. So, becomes kind of a lot of different questions that we need to answer before we can even get started. And then, even after that, when we have made those decisions, we still need to think about observability, about automation, about, how do we work together? Because most likely you're not going to be working all alone on your application. You're going to work with a team. So how can we make that into a more productive way? And so, yeah, it's a lot, right? It's a lot to think about. So what I'm offering is a highly opinionated approach, because you can go very many different ways. So I'm going to give you my approach, and that is, of course, using enterprise open source and Red Hat solutions, of course, because why not? So first thing that we need to think about is a software stack. And so what I'm proposing is Quarkus. And who actually has heard about Quarkus? Okay. And yeah, so for those who don't know Quarkus yet, it's a Java stack. And their slogan is supersonic subatomic Java. So supersonic because it's really fast. Subatomic because it's really small, and Java, obviously, because it's Java. And so our little friend there, Mr. Duke, that's the Java mascot, he's a fan too. So Java basically is an enterprise-grade, cloud-native Java stack. Now, there's a couple different approaches you can take about why somebody should care about Quarkus. My favorite approach is, the developer experience about it. Quarkus, as a Java stack, provides some nice advantages versus a more traditional Java stack. So one of them is that you can do live reloads without having to recompile, redeploy, so you can immediately just save my code, refresh my browser or whatever I'm testing, rerun it, and it picks up just the changes that I've made, And so I get a quick, immediate feedback loop. And the same thing goes for testing. So, you know, if we're thinking about unit testing, I make a code change. I don't need to do anything. It's just going to pick up, hey, you made a change, so I'm going to rerun that particular test that's affected by that code change. And vice versa, if I'm making a change in a test, it's only going to rerun, you know, the test and cover the parts of code that are relevant to that, which is nice. You get quick feedback loops, and you don't need to wait and recompile or manually start tests or anything. You can work, you know, pretty fast with that. So another couple things that are interesting with Quarkus is, you know, there's a lot of hype around native compilation of Java applications, not just Java applications, because in containers you don't necessarily need, you know, all the kind of things to make it compatible with, you know, it needs to run on Windows and on Linux and on these different stacks. Basically, you just compile your application to, you know, whatever the native runtime or the native spaces of a container. So, you know, typically a container is going to run in Linux, so let's just compile it native to a Linux executable, and you're going to have a lot of advantages with that. The nice thing is that with Quarkus, that's very seamless. So a developer can just say, you know, hey, compile this as a native binary, and it's going to take care of all of that. In Quarkus, you have some really nice advantages too in terms of developer experience with dev services, where you basically, let's say you want to use Kafka, or you want to use a, you know, specific database, or, you know, any kind of things. But, you know, installing a Kafka on your local machine is kind of a pain, right? I mean, because you have to install all different components and really need to have some knowledge about Kafka. But actually with Quarkus, you don't need to do that. If it looks on your local machine, you know, looks for, you know, in the case of Kafka, hey, do you have a Kafka cluster on your local machine? Do you have it wired up? If not, hey, no problem. I'm just gonna pull down a container and run a Kafka cluster for you, wired up. And so you as a developer, you just need to say, hey, I want to use, send some messages to this particular topic, and there's going to be a Kafka running on your local machine. And the same with a database too, right? So if you have, you know, maybe I want to start a Postgres database, I'm working on my local machine, it's going to pull down a container with a database, and then I don't need to worry about that. And then last but not least, in terms of the Quarkus developer experience, there's a whole kind of ecosystem of extensions. And so, you know, Hibernate, for example, or again, Kafka, or a particular database, or, you know, there's a whole bunch of them. The nice thing is that you can basically extend your code base, and you don't need to worry about all the different versions that you need to maintain then and go look and see where do I need to get those. It's all basically in the same place in the Quarkus Quarkiverse. And so maybe it's easier if I just give you a real quick overview of what that means. So what we'll do is I'll start a brand new little project, start a new window here. I'm using VS Code. And there's a Quarkus extension or a Quarkus plugin for it. There's the same thing for IntelliJ, or you can use, you know, whatever is convenient for you. There's Openshift dev spaces, or there's GitHub code spaces, and so on and so forth. All right, so here, you know, I'm basically starting a new project, and then I can say, hey, since I already have this Quarkus extension, I hope this is big enough. If not, you know, stick up your arm and say, hey, this is not good. All right, so generate a new Quarkus project, and I want to use Maven, and sure, I want to use 2.14, which is the latest stable version. And for those who are familiar with Quarkus, you can see there's already a 3.0 that's coming down the pipeline. So around the spring, I think that'll be a stable version. And then I can choose, you know, by package name and whatever more, and include some starter code, sure. And then last but not least, here you have those extensions that I was talking about. So you get a whole bunch of extensions that you can choose from. You know, there's a whole lot of them. I'm just going to use one, which is REST Easy Classic, so I can have a very basic REST endpoint. And somewhere behind my Windows, it's telling me I need to pick a folder. So let's do that, workspace. Let's put it in, yeah, sure, that's fine. All right, so creates me a brand new project, and you know, for those who are familiar with Java, it's, you know, very familiar because it's Java, right? I mean, there's no magic behind the scenes. It's very much standard compliant. And so here I have an endpoint, hello, and it says hello, rest easy. And so now I can start the Quarkus dev mode, which is basically a mode to run Quarkus on your local machine real quick. And that's what does all the kind of magic stuff with those devs services and running it on your local machine. So I started up this Quarkus dev mode, and if I go to my browser, localhost 8080, yay, I have a Quarkus application, and I have my endpoint that was generated, hello, rest easy. And so if I go back to my code and I change that, so hello, Belgium. And I don't need to do anything else. It just picks it up, hello, Belgium, which for some programming languages, this is like, well, okay, well, what's the big deal? For Java, this is a little more exciting, right? You get a little faster feedback. And, you know, so I can work very quick and have quick feedback. And it's the same thing with tests, right? So right now, if you look down here at the bottom, it says press R to resume testing. So basically, my continuous testing isn't by default on, but I can turn it on. And so now Quarkus is going to see, hey, there's a unit test. I'm going to run it, and it failed. Okay, and let's see why it failed. Because it's expecting hello, rest easy, and we changed it to hello, Belgium, with, I believe, 2 exclamation points. And so automatically Quarkus reruns that test because it sees, hey, something has changed. And now it says, you know, all tests are passing, you're good. And I didn't need to like do any kind of crazy magic. And if I now change this again, because I want 3 exclamation points because this is so cool, then it immediately tells me your test has failed. So, which is nice to get that feedback. All right, and now we can fix it again. All right, so what's also cool with this dev mode is that it comes with a dev UI. So if you go to /q/dev, it shows you, this thing almost fell. It shows you some stuff about the application that you're running. So it shows, you know, what kind of beams are running in your local machine, how many, you know, what it's going to remove when it's going to run, because Quarkus has some magic behind the scenes that I'll get back to in a second. And then it shows the dev services too, which right now I don't have any dev services, but you know, if I add an extension, let's say I want to add Hibernate, let's do that again. I want to add an extension to my project, and I want to add Hibernate ORM with Panache. That's right, Panache. All right, and I want to use Postgres. That's not the right one. Postgres. That's the right one. We'll just take that one, the other one with us. All right, so automatically it reloads my project, and then you can see here it's looking for new extensions, and then, you know, if the internet wants to collaborate, then you know, it's going to add those new different pieces. And here you can see, hey, it's doing a bunch of stuff, and that was pretty quick. But basically, because I added a Postgres extension, it's pulling down a Postgres container. If you were really quick, you could see it. And so basically now it's running a database on my local machine. So I didn't need to install anything, it just kind of did that automatically. And then in this dev mode, you can see now that it added this new information immediately to my dev mode 2, and it says, hey, I added this database, automatically configured it to wire it up with my application, and then I could even add that to my configuration and everything. Anyway, I'm not gonna go into it too much further because then our time will be up very quickly. So we'll go back to the slide. So I don't want to share it. I want a slideshow. And so that's that dev spaces that I was showing. So the same thing with all these different components, right? But so that's really cool for developers. You can make them really productive, and it's actually quite fun to work with, at least in my opinion. But for the more, let's say, operations-focused people, Quarkus is really interesting too. So first of all, you know, for, let's say, the architects, Quarkus is very much based on Java standards, so it doesn't like try to reinvent the wheel and a bunch of new different annotations and everything. It really tries to focus on standards, so you don't need to, you know, do this big migration. But what it does, it tries to move a lot of its what you usually do during you know, during the startup of a Java application. It tries to move that to the build phase. It tries to minimize the runtime dependencies, does this kind of dead code elimination, which basically means that it's trying to optimize as much as it can during the compilation of the app, so that when you start it up, typically in a container, it starts up really fast compared to a traditional Java application that isn't really super fast, right? Because traditional Java is meant to be long-running, stable, and the startup time isn't that important. But with containers, it's really important, right? Because you might scale your containers, they might be rescheduled on a different node, and you want them to start up quick so that, you know, they're available, right? And so that's what Quarkus tries to do, is, you know, use that knowledge that we have of Java, and then, but have the advantage of, you know, maybe one of the faster languages, and have the best of both worlds. And then, so you can run Quarkus on the JVM, which has some advantages. And you can also, like I said before, compile it down to a native binary that you can just put in a really small micro container that just has your Linux binary, and, you know, so you have small containers that start up really fast. So here you can see, for example, a test that we did a couple of years ago, and then you have, you know, a traditional Java application that, in terms of memory, used 136 megs, which, you know, was a fairly small application. Then it was rewritten in Quarkus, running on the JVM. You can see, wow, that's already quite a bit less memory that's using. And then compiled down as a native binary, you can see 12 megs instead of 136. That's quite a difference in terms of memory usage, right? And then in terms of startup time too, you can see here, you know, that traditional Java stack took 4.3 seconds, and down with Quarkus to 0.9 and 0.016 seconds. So the startup time is much, much faster, which lends Quarkus to a lot more use cases in terms of, you know, scaling, in terms of serverless, and so on and so forth. So, you know, that's why I picked Quarkus as my go-to stack, in my opinionated approach. So then, okay, I made my choice. I'm going to use Quarkus because, you know, I already know Java, and it has the robustness, and then now I can use it. Really cool developer experience, starts up fast, less memory. I can have a lot of density on a cluster with that. Now, you know, how do I build and package the application? So I was talking about native compilation and JVM. So it's not really clear-cut that you should always run your application compiled down to a native. There's actually some advantages to running it on the JVM. So kind of depends on your use case, right? But so if you want to run it on the JVM, you know, if you're looking for the best performance, the best garbage collectors, if you're really looking for those kinds of specs in your application, then it probably makes sense to still run it in a JVM. Yes, your container will be a little bit bigger. It'll start up slightly more slowly, but you're going to have more performance advantages. On the other hand, if, you know, what you're looking for is, you know, the very fastest startup time, the highest memory density requirements and everything, then it makes sense to go with the native. So kind of depends on your scenario. And then, you know, yes, typically you'll probably want to run it in a container. And so you have a lot of options there, right? So, you know, you can use Podman or Builda to build your application. You can use build packs, you can use Canico, Shipwright, Jib, kind of, you know, there's some advantages to everything. I don't have like a personal clear winner. It kind of depends on my use case. But the nice thing with Quarkus again is that, remember those extensions that I was talking about? Well, there's extensions for these. So again, I can just add an extension to my Quarkus code and then build it the way that I want to. So let's say that with my application here, oops, I just want to build it in a traditional way. I want to use Docker. And actually, it's called Docker, but on my local machine, I'm running Podman, but it's the same kind of deal. I'm adding the Docker extension, and then if I go back, and actually I need to start my dev mode again, because I just stopped it. And then if I go to my browser, go back to my dev services, or my dev view, and it's probably still reloading. We'll give it a second. There we go. All right, so now you can see that it added this little box container image, and you know, so I can use Maven to build my my Java code and build a container, or I can just use the UI right here. I can choose, you know, what kind of application I want. If I want a native build, or I want to build a jar into this container, it doesn't matter. And then I can choose build type Docker, and automatically Quarkus is going to build my container compile my code and build it in a container. So pretty handy stuff. And so there's a whole bunch of extensions like that for Kubernetes, where if you add a Kubernetes extension, it's going to create the manifests, you know, so all that YAML code that developers don't necessarily care about, that you can deliver to your delivery team. An Openshift extension, a Knative extension, and so on and so forth. So there's a whole bunch of them. But again, we're running out of time. All right, so now we've made those choices, right? So let's say that I chose to do a Quarkus build as a native build, and I put it in a container. And so now we need to decide, you know, how are we going to deploy this? Because there's many ways to deploy an application. So, you know, you have your choices of, you know, going to deploy it in some way to Kubernetes, maybe in a very, or a more traditional way on EAP or something, or on WebLogic or something. You can go with functions as a service in some way. But, you know, in my opinion at least, Openshift makes that a lot easier, because, you know, you have different deployment options with Openshift. I'm not going to go into that too specifically in this session, but I'm assuming that since a lot of you are Red Hat customers, that you know in some way how to deploy it, but if not, you know, we can talk about that afterwards. But we also need to decide where to deploy it, because, you know, maybe we want to deploy it on premise, maybe we want to deploy it to Microsoft Azure or AWS or blah, blah, blah. So we need to decide where we want to deploy it. And the nice thing, again, you know, is that Openshift allows you to deploy it kind of on any of those. And, you know, open hybrid cloud for the win. Yay! But again, we're not going to go into that too deep. Just know that, you know, Openshift runs pretty much anywhere, and I think most of you are already aware of that. So then we go and we need to automate our build. We need to deploy it in some way and have that become a, you know, kind of a sustainable process, right? And so before we go into the specifics of that, let's play a game. So who here has a cell phone? I hope everyone. Yeah. So basically, we're going to play this little game where we're going to generate energy for these little cars to move on a track. So we're going to split up into two different teams. You know, it'll be automatic. It'll be on your phone. And basically, this is what you're going to see on your phone. You're going to see a windmill to generate power for these cars. So, so the first time we're going to run this, it's going to be fairly basic. You just tap on your phone, and that generates the energy to drive these cars, and then we'll see how that goes. And then afterwards, we'll see, you know, kind of how we can automate new deployment in a way that's more manageable. But first, let's play the game. So grab your phones, please. I hope I'm not blocking your way.
It's taking me to your LinkedIn.
It's taking me to my LinkedIn.
Just a picture.
All right, so hopefully everybody can see like waiting for game.
Yeah.
Yes, okay. All right, everybody good with scanning the code? A couple more. All right, so I have the dashboard here, so you guys see, you know, or you all see waiting for game. And so let me refresh this, and then we should see, oh, I need to log in. And then, all right, so all the players are loading, so it looks like team 1 has 30 players and team 2 has 30 players, so nice. Oh, team 2, 31, okay. So if everybody's ready, I'm gonna hit the start button, which is a little bit hidden here. And then you're gonna, the windmill will show up, and then you just tap, and whoever, we'll see who wins. All right, let's go. If it loads, hang on. Is it loading? It's kind of thinking about it, isn't it? Is it working? Okay. But we don't see the cars moving. I'm gonna give it, okay, I'm gonna reload the page. Okay, now they're going. Okay, so we have team 2 that's taking an early lead. Come on, team 1, tap faster, tap faster. Oh, team 2 kind of stopped for a second. And team 2 won. All right, so who had the username Wyrambelski? Nice, you were the best tapper, good job. All right, so why are we playing this game? Because obviously it's running Quarkus. It's running this Quarkus extension called Quinoa, which provides the username or the user interface, and it's of course running on Openshift. And so let's say that I want to now make a change to my code. I want to make it so that instead of tapping, we're going to mimic a little bit more this whole kind of energy idea. And instead of tapping, we're going to shake our phone. So it's a little bit more like a wind turbine, right? So we'll do that in a couple of minutes. I'll first, you know, I need to make all my code changes. So of course, I already had this feature built. I just need to release it. So we're going to enable shaking and disable tapping. And then, yeah, commit straight to main branch, YOLO. And so what that does is actually in the background, yeah, and I have my little Openshift instance here that I need to log back into. Log in. So here's my application. So I installed a Kafka cluster just on my namespace. So I just use AMQ streams. You go to the operator, you click install, and basically that's all I had to do to have a cluster running on my Openshift. Oops, I'm gonna try to zoom out a little bit. So this is my Quarkus application that's running the code, and then I have a data grid / InfiniSpan in-memory database to cache your guys' username. So I'm gonna, and then I built with Tekton a pipeline so when the code change happens, that I'm going to rebuild the application, redeploy it, and then automatically deploy it with Argo CD. So a little bit more in detail in my slides. So this is how the application's built. Of course, you know, at the bottom, RHEL or RHEL Core OS at least. Openshift, I'm using AMQ streams for handling the events, right, to stream them. And then I have my Quarkus, Kafka, and Finispan. And then, yes, somewhere there's also an ACS that's scanning my application for security vulnerabilities. But there's going to be sessions afterwards about ACS, so we're not going to go into that part. And then once I've rebuilt my code, I'm going to push my container image to Quay, and I'm going to update the digest of that particular image tag in my Kubernetes manifest that then Red Hat GitOps will detect and say, hey, there's a change, there's a manifest change, so I'm going to redeploy this application. And so we'll see that in a minute, how that works. So yeah, the architecture is not that important. So we're adding this new feature, right? So hopefully it'll work. If not, you know, we'll have fun stories to tell afterwards about how Kevin's demo sucked. But anyway, so for those who aren't familiar with Tekton pipelines, which is what I'm using, so it's basically a way to declaratively use pipelines. You basically just declare, hey, this is my definition of a pipeline, which uses a few tasks. So a task can be git clone, or it can be you know, a unit test or a Maven build or whatever more. So every task then comprises of a few steps. So every component of that is declared as, you know, a piece of basically YAML code. And so you can reuse the same components between different pipelines and define it all. And then once you call a pipeline, it'll read that code and it'll start a step or a task in your pipeline, which means that you don't have a central server to configure anything. It's just, you know, kind of declarative code, and then everything else kind of gets picked up. It runs a task and then, you know, destroys the container. So it's a nice cloud-native way to run CI/CD pipelines, and this is integrated into OpenShift. So for me, this was the way to go. Of course, if you have a different CI/CD solution, that will probably work with OpenShift as well. But so I used Tekton pipelines, and then I used Argo CD embedded in OpenShift with OpenShift GitOps to deploy the application. So basically, what's nice about GitOps is that you can configure your application in some way. You can say, hey, these are my Kubernetes manifests. I can customize some components. And then every time something changes, I need to define that in my code so that I can see who changed what, where, and when. And then if we need to roll back or do some kind of audit or something, we know exactly what changed in the cluster. And then in fact, if somebody does go into the cluster and changes something, Argo CD will either remediate automatically, or it will notify you and say, hey, something changed here that's not defined in your log in your Git, so that's not right, so you should do something about that. So that's basically, so Git is a single source of truth. You treat everything as code, and then all the operations just go through Git workflows. So if we go back to our application and my pipeline here, so here you can see that our pipeline fortunately succeeded. So you have this concept of pipeline runs, and here we can see that the latest one, basically what I'm doing in this pipeline is fairly simple, right? I'm doing a git clone, then I do my Maven build and test, then I use builda to build the application, and then push it to Quay. So here you can see, for example, in Quay, that it pushed this new image based on, you know, that code change that I made. It automatically pushed the image, and then you know, it even scans for vulnerabilities. So I need to update that a little bit, but nice to know that there's that it picked up on those. And then finally, at the last step of my pipeline, the digest here got updated to the specific tag, but not just tag, but the actual digest of that image so that I know this is exactly the image that I wanted to push, and then Argo CD will pick that up. And man, I have to log into everything. Here you can see though that it's nicely integrated with Openshift. Oh, bad request, fail. Let's try that again. Oh, this is interesting. The demo gods are playing again. All right, let's try it one more time, and if not, one more time. All right, so here's my application. And well, now it's a little late, of course, because the sync has already happened. But basically, it picked up that change and then did a rolling update of my pods. And maybe to show you one more thing here. So if I have my application and I have 5 pods running, if I were to manually go into my cluster and say, hey, I'm gonna scale down these pods, there's only 3 needed, Argo is gonna notice that and say, hey, that's not right. You need to have 5 because that's what you declared, and so that's what should happen. And then you can see that it's scaling back to 5, so it's going to remediate the changes that somebody tried to do manually on the cluster, so that's kind of nice, right? So hopefully, because of our rollout here, if you now go back to the app and I can show you the QR code one more time if anybody needs it. If not, just refresh if you still have it. And so if everything's went well, there should be an enable shaking button. Yes, okay. Because last time that was not the case. All right, so this time, all right, first, before we do the game, fair warning, hold on to your phone, okay? Because I've seen phones fly around the room and that's not very safe. Okay, so if everybody sees that, let's just refresh. Because I redeployed. All right, so is everybody ready to shake? All right, and it should start. Okay, go ahead. I have to be quick with this, but. All right, team 1, team 2. Wasn't team 2 the one that won last time? I feel like some people don't think it was fair. Okay, we can do another round. All right, so the person who shook the best was the username Wimes or Weemus. Who was that? Nice. I don't know if we have any prizes or anything, but. Yeah, that's right. Shall we do one more game and see if team 1 can win one time too? Everybody should be a winner, right? Okay, I see. So team 1 has less players right now, but it doesn't matter. It's just the average of all the players. So if somebody doesn't play, then that drags the team down, right? So please all play. Ready, set, go. Ooh, we got team 1 for sure winning this time. I see there was motivation. Nice. Well, you're really good at shaking your phone. That's all right. So I hope I kind of showed you how developers can be more productive, how you can use Quarkus to build something really fun too. It's not just kind of like boring code, but you can also write boring code. How you can scale easily, how you can use Tekton pipelines and Gitops to make deployments really easy. There's a lot more things you can do with Quarkus. You can add, really simple, you can add an extension to add, liveness endpoints. And, so for your health endpoints, you can add metrics and to have more insight into your application, and you can integrate those into Openshift observability or add them to Prometheus. There's a whole lot of really cool things going on with Quarkus these days. So it's a cool project, and I highly recommend you take a look at it. The nice thing is that it's included in your Openshift subscription. So if you're running Quarkus on Openshift, it doesn't need a separate subscription. It's basically just included with Openshift, which I think is nice from our business units to do that. And then, yeah, I hope I also quickly showed you how to use, for example, a Kafka with AMQ streams. So you can use Kafka with Quarkus on your local machine. You don't need anything else. And on Openshift, you just basically use AMQ streams, or you can use a managed Kafka through Red Hat. And then you're off and running with fun stuff real quick. And I think that concludes my session. So thank you. And then up